Yeah.
Okay, so let's finish this off. We got, what, 4 questions to do or something? So during round robin play in a badminton tournament, there were 210 games between the mixed doubles teams. If every team played every other team once, then algebraically determine the number of mixed doubles teams in the tournament. Okay, so if we're going to have every team play every other team once, how are we setting that up? We could say fancy stuff like, let n be the number of teams. And then what will we say with that? So how do I put those teams together to play each other? It's like yesterday never happened. Fine. Look at number 10, for God's sake. Okay, so it's going to be n choose 2, right? We have n teams, we want to pair them up without regard to order, because you're only playing once, right? It's a round robin thing, I think they call that a round robin tournament, right? Like you play everybody once and then you start to break out the brackets. So we know that in this tournament there were a total of 210 games played. Every team played every other team once, and I guess they just picked standings, so it doesn't sound like they then played off. Okay, so n choose 2, n factorial over n minus 2 factorial, 2 factorial. So that's straight off the formula sheet, right? That's just the definition of n choose 2 is equal to 210. We're going to multiply both sides by 2 factorial, which is really just 2, right? So we're going to get n factorial over n minus 2 factorial is 420. Okay, let's do 210 times 2 factorial. Be a little, not that kind of tournament. It's not legal yet. Yeah. And you should wait till you're 25 anyways. Your little brains have to mature. That's actually serious stuff. Like if you really want to look into this. Okay. And if you're going to do anything like that, you should be looking into this. This is all being recorded, but I didn't say anything. Right? Nobody knows this, so it's like references. What's he talking about? Okay, so we expand the factorial, start with the larger one, work it down until you get an expression that's this smaller one, and then just throw a factorial sign down and stop, and then go n squared minus n minus that's equal to 0. So you're looking for a number pretty close to the square root of this, right? Which is like what? I don't know, what are they? 20 and 21. So it's going to be n minus 21 and yeah. So if you're ever factoring something and the middle term is like a small number, then it's going to be close to the square. That's where I would start. Like, what's the square root of 420? It's like 20 point something. Oh, okay, let's try 20. Oh, 20 and 21. Okay, boom, done. You can also look in the table, right? So to verify this, you could do x choose 2 in your calculator, and then simply scroll down. Go into the table, don't graph it. Go into the table, and then scroll down until you see 210, and you'll know that x is 21. And also, negative 20, which you're going to reject. Because you can't have a negative number of teams, right? Okay, good. Questions? It's going to be a collision. Go over here. All right, so n choose 2 is 210 algebraically. Can they ask you to do it algebraically on the diploma? No, you can't algebraically determine anything. But how can they ask? They can show you a set of steps, right? So, or if like Joseph is going to algebraically determine blah, a step in the solution might be, and then they show you 4 expressions, right? And sometimes that goes, sometimes the step isn't a step that you would necessarily do, so you got to be a little flexible, right? And say, well, we did stuff a different way, right? But okay, let me try different things. Solve for n if 720 times n choose 5 is equal to n plus 1 p5. So here we can mix. Now again, we can ask you that, right? That's a legit question because you have to show work and algebraically determine. As a multiple choice or numeric, it really doesn't work well because You just throw it into your calculator. Anyways, we got to do this. So 720 times n factorial over n minus 5 factorial, 5 factorial. Okay, so again, we're just defaulting to the formula, right? So on your formula sheet, let's throw that over 1, is equal to n plus 1 factorial over n plus 1 minus 5 factorial. I like to throw the brackets in there because it just sort of, but you don't need them. You could just write n plus 1 minus 5. I like to throw it in because it just sort of reminds me, oh, that's my n, right? Because that's n and that's r in the formula. Okay, so let's go 720 n factorial over n minus 5 factorial, 5 factorial, is equal to n plus 1 factorial over n minus 4 factorial. Okay, well, wait, what's 5 factorial? It's like 120, right? So factorial, this is 120, that cancels, so we got 6. 6n factorial over n minus 5. Let's clean that up. We'll write it here, it's okay. You know, if we've done some cancellation, it doesn't hurt to throw in an extra line. Right, keep things clean. Okay, how are we going to solve that? So kind of look at it and say, hey, you know what? If I expanded n plus 1 factorial, what would I get? N plus 1 times n. And if I were to stop there and just write n factorial, and I had an n factorial on both sides, I could divide both sides by n factorial, right? So think about this. We're not necessarily going to do anything. We're looking at strategies right now. Okay, so if I wrote this as, don't write anything down, n plus 1 times n factorial, then I could cross this and this off, right? Just say divide both sides by n factorial. Okay, so that's legit. And then say, hey, wait, this one's bigger. If I wrote n minus 4 times n minus 5 factorial, then I could multiply both sides by n minus 5 factorial. These guys would disappear. And then I'd have something that I think solves pretty easily. An alternative to that would be to say, let's do this. Okay, so let's kind of cross multiply and then divide. Okay, so here, I'll just show you, let's do the cross multiply first. So 6n factorial times n minus 4 factorial is n plus 1 factorial times n minus 5 factorial. Okay, so that's just a straight cross multiply, right? So we know that's all nicely equal. And then we could say, well, let's divide so that we're going to have like our things that are close to n on 1. So we'll do 6n factorial over n plus 1 factorial is equal to n minus 5 factorial over n minus 4 factorial. All right, and now we can expand, right? Because we know we're going to expand this. We'll hit an n factorial. We'll cross those off. We'll expand. Which one's bigger? N minus 4. We'll expand that. We'll cross those off. Then we'll cross multiply again and solve. So let's just pop up here. So 6n factorial over n plus 1 times n factorial is equal to n minus 5 factorial over n minus 4 times n minus 5 factorial. Okay, so we'll stop, right? So it's the usual factorial stuff, right? Just expand the larger one until you hit something that's equal to this and then throw a factorial sign down, right? So 1, 1, 1, 1. Okay, let's cross multiply. 6 times n minus 4 is equal to 1 times n plus 1. 6n minus 24 is n plus 1. 5n is 25. And n is 5. Okay, go to verify that. Go 720 times 1 which is 720, and then go 6p5. Does that work? I don't think that works. I don't know. 720 times 5p5 is 6p5. Oh wait, that's 6 times 5 times 4 times 3 times 2. Okay, yeah, it's true. It works. I was mixing up my p's with my z's. So 6p5 is just 6 factorial over 1 factorial. Right, 6 minus 5. So it works. You could do it in your calculator too, right? So you can verify this in your calculator. You do have to show it algebraically, but you can verify stuff in your calculator. So to do that, just go to y equals 700. You can do 720 times x math PRB 3, 5. Okay, so 720 times x, choose 5. We can't do ends. And then x plus 1. So let's throw that in a bracket, right? Because we're going to do x plus 1. And then math and over to PRB. And that was a 5 as well. Go into the table. Don't graph it. You don't see anything to graph. Go down the table and you say, I'm looking for 720. Right? Both of them to be 720, right? Or sorry, I'm looking for both of them to be equal. I'm not looking for both of them to be 720. I'm looking for the line on which these two are equal, and it happens to be 720 and x is 5. Okay. Make sense? That's verification for you, right? So, you know, I don't know. What do you like to do? Would you like to? It's like, how many people look at the back of the book before they actually read the entire book? Does anybody, kind of flip to the back just to see? Yeah. So not many. I don't. I can't do that. But some people like to know how it ends, right? Before they read it, and that's weird to me, but that's okay. So if you want to know how it ends, plug that into your calculator, solve for n, right? And now you know I'm aiming for n equals 5, right? So if I can get something that comes out to 5, I'm good. Okay. If I don't, then I know I made some mistake. 5 statements are shown below. Okay, so this is a kind of question, right, that you could get on a diploma. Number of root salads, it would be numerical response, although it could also be phrased in multiple choice, right? The answers are like, assume 1 and 2, 1 and 4. Give you different options. This would be one of those numerical response where you could answer in any order. So if the answers were 1 and 4, it would be 1, 4, or 4, 1. And the machine is keyed to allow for those two answers, right? What we did, so when you get your stuff back, the numeric response that were out of 2 marks, we gave a half a mark for each correct answer. But we only keyed it so that it gave you 2 marks if you had the correct answer. So you'll see some little crossing off and writing in, and the total that was given at the top, you'll see that perhaps crossed off with a new mark written in. And that's because we were keying 3 and 5. We were marking those, going back and looking by hand. And also, I think for number 4, which was like a true-false, if you got 3 out of the 4, we gave you a half. And then for the one that was like a 2-digit answer, we gave you a half for each of those. It was out of 1, we just gave you a half for each, if you did not get it correct. Anyways, all that's good. 14 different fruits are available for a fruit salad at a cafeteria. Johnny orders a $3.95 special, which contains any 5 different fruits. The number of different fruit salads that Johnny can order can be found using statements, blah, and blah. Is this permutation or combination? Do we care what order the fruits are chosen? No. So it's not a permutation, right? So there goes statement 2. Okay, so what's valid? What's left that could be it? So look for the obvious one. What's the obvious one? Statement 5, right? 14, choose 5, right? Okay, makes sense? There are 14 fruits. I'm going to choose 5 of them. I don't care about the order. Okay? What is 14, choose 5? It's 14 factorial over 14 minus 5 factorial, 5 factorial. Okay, so is that in there? Okay, yeah, it's going to be 3. Okay, because what's 14 choose 5? Same as 14 choose 9, right? It's like, okay, tell me which fruits you don't want. and I will give you the other 5. Okay, so maybe you try this and say maybe they expressed it this way. Okay, they didn't. All right, what next? Right, what am I looking for? Oh yeah, 14 choose 9. That's the same way, right? Don't multiply it by 5. It's just 14 choose 9, and it's not that because I can see it's this, so that takes this statement out of the running. Okay, so I mean, what have we reasonably eliminated? It's not a P and it's not statement 1. So that means it's either, well, it's like it can't be this because if I take this and multiply it by 5 factorial, those go away. So it's not this one, right? So we processed of elimination our way to the answer, right? It's like, even if I didn't know it was 14 choose 9 or that didn't enter my head at the moment, oh yeah, 14 C5 is the same as, then it's the only statement that's left. At which point you go, why is that the same? Oh, right, because I could not choose 9 fruits, right? Like, don't give me those 9, and then that gives me the 5. Okay, determine the number of different 4-letter arrangements that are possible using 2 letters from the word smile and 2 letters from the word frog. So there are 1, 2, 3, 4, 5 letters in the word smile, and we need 2 of them. So we're going to go 5C2 because we're going to have to choose the letters from smile, and then from frog, choose the letters from frog, which is 4C2, and then multiply that by 4 factorial to arrange the letters. And that will be equal to 1440. So we do want a permutation, that's the 4 factorial, but we have to choose these letters first before we can arrange them. So 5C2, take 2 letters without arranging them, and 4C2, take 2 letters without arranging them, and then arrange the 4 letters. Now in 15, determine the number of different 5-letter arrangements using 3 letters from the word tab, which is all 3 letters. So we're going to have to do the same basic idea. The only problem is there's an A in tab, and it is possible that an A from chai could be chosen. So how do we handle that? Let's say we don't pick the A from chai. Don't pick A from chai. So if we don't pick the A, then let's deal with tab first. So we're going 3C3. So remember, we're choosing the letters first, then we'll arrange them. If we don't pick the A from chai, then we've got 1, 2, 3 letters, and we need a 5-letter arrangement, so that becomes 3C2. In this case, there will be no repeating letters, right, since we have a T, A, B, and a C, H, I. And those are all different letters, so then we'll multiply that by 5 factorial. And that works out to 360. What if we do pick the A from chai? Pick A from chai. Then we have the 3C3 letters from tab. Letters from tab. Then we choose the A from chai, which is 1C1. I suppose I should have written that as chai or chai. So we choose that, 1C1. We now have 4 letters. So from the remaining 3 letters, we need 1 letter times 3C1. And we've got 5 letters, so these are our 5 letters, 3 from tab, the A, and then 1 remaining letter. Those can be arranged 5 factorial ways, but we know that we have a repeating letter, because we do have the A here, and we have the A from up here, so the 2 A's requires us to divide by 2 factorial, and this works out to 180, giving us a total of 540 possible different arrangements.